All right, good morning, fourth grade. This is day 2 recording, the work for day 2. So we're going to get to that, go through here, and talk about, last time was equivalent fractions. And so you have to be able to make equivalent fractions, very important. And this time is about comparing. So how do you compare fractions, which are larger, smaller? And it all has to do with, what do you know about the numerator? I'll put an N, and what do you know about the denominator? So for example, if I was going to compare 7/8 and if I was going to compare 7/9, for example. So if you know that this numerator down here with the 8 means that that pizza has 8 slices to make a whole, you would know this pizza has, with the 9, it takes 9 slices, so more slices. So if you can think about those pizzas, 2 pizzas, same size, 2 pan pizzas, but one is cut into 8 parts and one is cut into 9, so more parts. Then if you take an equal number of parts from the first pizza, that's that 7, and an equal number of parts, take 7 slices from the second pizza, you got the same number of slices. So now your question is, well, which slices would be bigger? And if you understand that, if you can understand that, that's really going to go a long way. In the example I just gave you, this would be larger. Okay? And I'll quickly just show you. Here is a pizza. Now I may not actually be able to draw this one very well because it's hard to draw really precise there, but so there's I'll cut these. Okay? And then I've got to do 8 slices all the way across here, so hold on. 1, 2, or 8 lines. 3, 4, 5, 6, 7, 8. So I didn't draw that very well. It's hard to draw. And let's see, can I get a pen that will let me fill something in? Oh boy. So this would be 7 slices. 1, 2, 3, 4, 5, 6, 7. And here would be 7. 1, 2, 3, 4, 5, 6, 7. And it really should be over, even a little closer, but there's some proof, at least, not drawn really well, that 7/8 is greater than 7/9. So really think about that. Okay, so let's take a look at our examples here. I'll take that off because I'll need that room. That's the kind of thinking I want you to do, though. What do those denominators mean, and what do those numerators mean? If you understand that, that's the goal. Okay, Sandy ran 3/10, and Alicia ran 1/10, and Rosa ran 3/8. So we're going to compare the distance Sandy ran to the distance Alicia and Rosa ran. Okay, so first we're comparing Sandy and Alicia. And Sandy again ran 3/10. And Alicia ran 1/10. So that's pretty easy to compare. Here we have 2 fractions, and the denominators are the same. And Sandy has 3 more. If that was a pizza, it'd be 3 more parts. But this is a mile, so she ran 3 more parts of a mile. So that's pretty easy. If we look down here, we see they do the comparison for you. 3/10, they use the symbol as greater than. Okay, over here, let's take a look. We have Sandy. Pick a different color over here. Sandy has 3/10. And this time we have Rosa, and Rosa ran 3/8. So now we have a different type of comparison. Whoops. Now we have, and I didn't write that very well. Let's see if I can erase it. Now we have the same. Notice what they're doing. They're trying to get you to see. Here, the numerator, we have the same number of parts. That was like my example I gave you. Same number of parts. Look at Sandy has 3 parts. 1, 2, and 3. And look, Rosa has 3 parts. 1, 2, and 3. But what's interesting on this one, what's really interesting is the denominator. The number of parts to make a whole is different, which means the size of the parts are different. In this fraction, it takes 10 parts to make a whole, so those parts have to be smaller. And in this fraction, 3/8, it takes only 8 parts, so fewer parts to make a whole, so their pieces are bigger. So there's two examples. Over here, we have the denominators are the same, number of parts you have is different. And over on this side, we have the number of parts you have is the same, and the denominator is different. All right, well, let's get going. We'll do some more comparing here. Here we go. It says, look at the problem, the example in the problem above. Write each comparison in words. Use greater than, less than. So we would say 3/10 is greater than, and that's the symbol. And you're always going to point to the smaller number. So that will help you to remember. Just point to the small number, okay? And then greater than is how we'd fill it in. Now we have 3/10 is less than, that's how you say that in words, less than 3/8. That's what the symbol here, this time it's pointing, again, 3/10 is smaller, so it's pointing to 3/10. Okay, let's take a look at some of these others here. Let's pick a different color. I'll take this. Shade the models to show 2/8 and 2/5. Okay, so now they've already got the model. Now notice, this is, if this is a pizza, it's the same size as this. The total pizza, the whole pizza is the same size, but the parts are different. And again, look at this. We have the same number of parts for each one. We're going to shade in 2 parts. Our difference is going to be, this one has 8 parts to make a whole, and this one only needs 5 parts. So you can guess, look, let's do 2/5 first. Those parts are bigger. Look how big they are. 1 2/5. And up here, those parts for the 2/8, those are smaller. 2/8. Same number of parts too. The size of the parts here, where the denominator is 8, they're smaller. Keep thinking about that. That's the key. That's the whole key. Okay? All right, let's look at this comparison. All right, what do we notice? What do we notice? We have the same number of parts to make a whole. Look at that. 12 parts to make a whole. But we have a different number of slices, we'll say, if they're pizza. Okay, so in the first one, we have 5/12. Only 5/12. So we can already guess. We have fewer slices here with 5. And remember, we can compare these. This is easy because they're both the same size. So 1, 2, I mean the parts are the same size. 3, 4, 5. And over here, let's look at the other one. We'll just pick a different color. We have 1, 2, 3, 4, 5, 6, 7. 7/12. Again, we probably knew that because their denominator is the same, so that means if we have more of the same size part, like right here, that's going to be more. Now we got to compare it using symbols. So we're going to point to the smaller one like this. I always point to the smaller one, and then we would say 5/12 is less than. Ta-da! It says explain how you use the models in problem 3 to show how the two fractions compare in problem 4. So you would just say what you did when you use a mathematical in math. If you want to explain something, what you want to explain a problem, just explain the steps you did. So you could say, I shaded. This is one way to do it. I shaded in both models. To show the fractions 5/12 and 7/12. The models show, and then you want to explain, it says how the two fractions, how you use them to compare. So we shaded them in, and then we looked at them, right? So you can say them, one way to do it would be the models show. Again, just explaining what we did. We looked at them and said, oh look, 5/12 is less. That 5/12 is less than 7/12. Ta-da! That's all you did. And again, you can pause or go back. I'm just going to keep moving on here, okay? Okay, now this one says we're going to use a number line. So we have to be able to show fractions with, let's see if my color came out. Nope, it won't change there. Yeah, I can't get some of those colors I can't get to. Label 7/8 on the number line. So we're going to label 7/8. All right, so what does that mean? Well, this means that our whole is broken up into 8 parts. Now this time the whole is not, it's not a pizza drawing. The whole is this space from here all the way over to here. That's the whole, okay? And I could actually show that. Oh, I can't do it because this one won't give me the thick block to highlight on. You could think of it as a piece of string, that green string, okay? So that green string is going to be cut into 8 parts to make a whole. So here's the first part. Right? There's the first part of that string, right in between those 2 purple marks. And then here is the second and the third and the fourth. And again, what I'm talking about is talking about the string in between. We're actually counting the sections on a number. If it, we're thinking of it as a string, but on a number line, we're talking about the space. So this space right here, at the end of it, we would put 1/8 to show that at the end of that, that represents, that distance is 1/8. And then the next one, that distance over to here, now if I make 2 purple, show the space with 2 purple lines, that is 2/8. I draw a third one, I'm at the end of that section, I'm at the end of 3/8, at the end of 4/8. This marks the end of the 5th piece, the 6th, and the 7th piece is the 7th piece out of 8. And this is actually one whole piece, and I can also say it's 8 parts out of 8 parts. This is another way to say 1. Another way to say 1. Okay, so we'll do the same thing down here. We won't have to spend as much time. I think you got it. Label 7/12. That means that this whole has been cut into 12 parts. We'll notice there's 1 part. Remember, we're talking about this section on the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And again, look at this. Look, compare how big this little section of the line is. This part, that's 1/12. Compare the size of this part to the size of the part above for 1/8. And again, it shows you that denominator, it's 12 parts to make a whole. The parts have got to be smaller. We're cutting the whole up into more parts. If you understand parts and wholes, and you think about that, you can just really understand a lot of math. Okay, so where's 7/12? Well, there's 1, 2 12ths, 3 12ths, 4 12ths, 5 12ths, 6. There's 7/12 right there. I'll put a black dot here for both of that. 7/12 is right there. Whoops, didn't change it to black. There we go. And 7/8 is up here. Again, we're comparing 7/8 and 7/12. Same number of parts. We have 7 slices or 7 pieces, but boy, they sure are a lot bigger for the 8s. Okay, let's point to the small one. So 7/8 and 7/12. Even though the number 12 is larger, pieces are smaller, it is the smaller amount. Okay? So they want us to say here 7/8 to fill this in. 7/8, and this way we would read this 7/8 is greater than 7/12. 7/8 is greater than 7/12. And we come up to our last one, okay, for day 2. Explain how you use the number lines in problems 6 and 7 to show how the 2 fractions compare in problem 8. How do we use the number lines? How do we use the number lines? Well, what did we do? So you can say I labeled each number line. That was the first thing we did, right? We labeled each number line. We can say let's say to match the number of pieces in the whole. What I mean by that, to match the denominator, right? To match the total number of pieces. Like the first one had 8 parts, the second one had 12 parts. So we'll say I label the number lines to match the number of parts in a whole, or in the whole. What was the next thing I did? I located each fraction on the number line. When I say locate, that's where we put the little dot. I located each fraction on the number line. Then I compared. Then I compared them. If you think about it, that's exactly what we did. We labeled, right? We 1/8 and 2/8, and we talked about how there was 8 parts, and that matches our. We talked about it matching our denominator. Same thing down here for 7/12. We labeled each thing, made sure it matched our denominator, the number of parts. We put a black dot, right? Put a black dot where each fraction was located on the number line, and that allowed us to compare which one was bigger. That's it. That's it. If you understand parts and wholes, and the fact that when you break up a whole into, the more parts you break something into, the smaller those parts have to be. That is just a very, very powerful math statement. You're doing a great job. Hang in there. Let's do some more math. Meet me later for another video. Bye-bye.